So we're continuing with our balancing equations worksheet from last time, and we've got this equation in front of us. So sodium plus chlorine equals to sodium chloride. Okay, so all we're really doing is we wrote down the number of atoms. So the number of atoms on the left-hand side and the number of atoms on the right-hand side. So we can see here that we've got an equal number of sodium, but then the number for chlorine atoms is imbalanced. There's no balance there. Okay, we got more on the left-hand side than on the right-hand side. So what that means is I need to make this one into two. Okay, if I look at chlorine on this side, I see that chlorine is actually attached to another element. It's attached to sodium. I can't separate the two because that's a compound. So what I do is I think about what big number or what coefficient can I put in front of this compound to make there be two chlorine, okay, atoms. So the answer will be 2, okay, because if we go 1 times 2, that'll give us 2. And then that 1 will then become a 2, and these two will be equal. However, we have another issue that comes up out of that. When we put a big number in front of a compound, we said that it multiplies both with the first element in the compound as well as the second, okay? So there's imaginary ones here. So that means 2Cl, which is what we wanted, but now Na actually goes from 1 on this side to 2, okay, because that big 2 number coefficient multiplies with the small 1 subscript, okay? So now this side is imbalanced, okay? Now we've only got 1 on this side. Now, in order to make this 2, we've obviously got to multiply 1 times 2. So we look at where sodium is on the left-hand side of our equation, found it, put a big 2 in front of that. When you put a big 2 in front of that, you've got a little 1 imaginary subscript there multiplying with the big 2, and that gives us 2. Now, if we do a little cross check straight away, we see that that's balanced, 2, 2, and then the 2 chlorines are balanced as well, 2, 2, okay? So that's basically how we balance that equation. That's a really simple example, but just to recap our knowledge of how it all goes. Are there any questions or any confusions about this before we move on? No, you don't get rid of the little 2. All the little 2's always stay in their places. So whatever you started off with the equation, the Cl2, you never get rid of that. That stays where it is. We only add big numbers or big coefficients in front of the compounds. We never change the subscript. Okay, the subscript stays the same there. Okay, so that's basically, yeah. All right, let's try the next one now, guys. So let me just scroll down. Oh, first, let me delete whatever's on this screen. Clear all drawings. Okay, so let's go to the next one now. And I'm going to give you guys about, let's say 4 minutes. Okay, let's challenge ourselves a little bit. 4 minutes, use the same step-by-step procedure I just showed you, and try this one. And I'll pause the recording while you guys give that a go, and then we'll unpause when we look at the answer together. Okay. Okay, so if we look at the iron atoms on this side of the left-hand side of the equation, these are our reactants that we said last time, remember? So in our reactants, we've got 1 iron, we've got 1 oxygen, and we've got 1 carbon, okay? 1, 1, 1, just 1 of each. On the right-hand side, which are our products, okay? On the right-hand side of the arrow, we've also got 1 iron. We've got 2 oxygen, as seen by the 2 subscript next to the O here. And we've got 1 carbon, okay? Now, if we look at this, we can see that most of it looks pretty good and balanced, except the oxygen. The oxygen is what's kind of sticking out to us there. Okay, so in order to change the oxygen here to go from 1 to 2, I have to look at whichever compound or wherever O is, I have to put a number 2 or that specific coefficient in front of the compound. I can't just stick it in here. Remember, last time I said you can't just stick a coefficient in the middle of a compound. It's always got to go right to the front of the line. Okay, just think of it like a big bully. Remember, we said the bullies don't push in line in the middle, they always go straight to the front. Okay, so essentially that's what happens with our coefficient as well. So here, because we've got 2 oxygen and here we've got 1, obviously what do we need to times by 1 to get 2? It's 2. Okay, that's how you determine the number of your coefficient. So we look for wherever oxygen is, it's here, it's attached to the iron, that's the iron oxide compound. So we put a big 2 in front. Okay, that's our big 2. Now, everything should look good because now that 1 goes from being 1 to being 2. Now, so far that looks good. Okay, so far the 1 looks good, but the issue is when we put the big 2 in front of iron oxide, not only did there become 2 iron atoms, now we've also got 2 oxygen atoms, because remember there's an imaginary one there. Whatever coefficient you put in front, it always multiplies with every element or every atom in that compound. So we've got 2 iron now, but we've also got we've got 2 oxygen now, but we've also got 2 iron. So what happens now is this turns into a 2. And now iron is imbalanced. We thought iron was balanced in the beginning, but after adding that big 2, it became imbalanced now. We can easily fix that though, no big deal. All we've got to do is think about what multiplies with the 1 ion on this side to give you 2. That will be our coefficient. Okay, 2 is the magic number we're looking for, so it can be balanced here. 1 times 2 gives us 2. So we just add another 2 in front of the iron here, and that will be 2 iron, 2, 2, 2, 1, 1, and that is balanced. So that's all good. Okay, hopefully everyone kind of got the same thing or something similar. Sometimes, you know, when you do more of these, you don't even have to go through the step-by-step processes. You just look at it and you know where the numbers need to go. But this is just for us in the beginning, just to get your head around it kind of thing. Okay, so hopefully if there's no issues with this, we're going to go to the next one. So what I'll do is I'll just scroll down. Okay, so the next one is another equation. Okay, we've got silicon oxide plus carbon, and then we've got our products there that have formed. So again, I'm just going to give you guys about 4 minutes. So I'll just put 4 minutes on the clock. Just give me 1 second, 4 minutes. Yeah, okay, I'll give you guys 4 minutes to give this a go, and I'm going to pause the recording until, while we work on this now. Okay, so we just looked at this together, and to make this balanced, all we really need to do now is put a 3 coefficient in front of the carbon and a 2 coefficient in front of the carbon monoxide there, okay, to make it all balanced there. All right, so let's try the next one now, and I'm going to pause the recording again to give you guys a bit of time to work on the next one. Okay, so all we did here was we found out that chlorine was not balanced. Okay, in the beginning, we put a big 3 in front of it, which made it 3 sodium chloride. But then what we realized was that that 3 actually affects sodium as well. Okay, so that 3, when we multiply the 3 coefficient with sodium, that also becomes 3 there. Okay, now that becomes imbalanced. So what we did was to balance it on the other side, we multiplied the other side by 3 as well, and we chucked that 3 in front of sodium hydroxide. Okay, so now everything kind of fell into place because of the fact that oxygen and hydrogen are attached to that 3. They also get multiplied by 3, which means that everything kind of fell into place and got balanced as a result of that. Okay, so that is basically our balanced equation for that one. So what I'm going to do now is I'm going to clear the drawings now, and we're going to work on the next one. So I'll just pause the recording here while we work on the next one. Okay, so if we look at this, equation, we just need to count the atoms first. So we see we've got 1 aluminium, we've got 2 hydrogen, as we can see with the subscript 2, we've got 1 sulfur, okay, and we've got 4 oxygen. Where is it? 4, okay. And then on this side, we've got 2 aluminium, as you can see, the subscript or the bottom number is 2 there attached to the aluminium. Then we've got 2 hydrogen, okay, here. We've got we've got 3 sulfur, not 1, because again, the 1 subscript of sulfur multiplies with the 3 outside. So that's going to be 3 to begin with. And then the 4 subscript of oxygen will multiply with the 3 outside. So 4 times 3 will give us 12 oxygen. Now, we can see there's a little bit more balancing to do in this one than the previous examples. So all we really need to do now is we look at them, just go through it like sequentially, or just look at which one stands out to you the most to begin with. To me, the easiest one to deal with is aluminium first, because aluminium is all by itself on this side. It's not attached to another compound. So it's always good to deal with the ones that are by themselves or alone, like single elements or single atoms there, rather than dealing with the bigger. We'll deal with this part later. Let's deal with aluminium first. We've got 2 on this side of aluminium. Okay, the goal is to make it 2 on this side. That's my goal. So now I have to think about, what do I multiply with the 1 aluminium here to get 2? And obviously the answer will be 2. So all I do is I search for aluminium on the left-hand side of the equation, search, it's there all by itself. Then I just chuck the number 2 in front of it. Okay, that is a big 2. So big coefficient 2 in front of the aluminium. And now that 1 aluminium is no longer, now it's 2. So now aluminium is kind of balanced for us there, okay? Then the next step is to look at the other elements that we have. Okay, so if we look at, for example, another one that's not balanced to begin with is sulfur. Okay, sulfur has 3 on this side and it's got 1 on this side. So my goal now is to make this the left-hand side sulfur, 3. I want 3 atoms of sulfur on the left-hand side to balance it out on the right-hand side. Okay, so basically I look at, okay, what do I multiply by 1 to get 3 on this side? I multiply 3, okay? So then remember, guys, I can't just chuck a 3 in the middle here. That's not how it works. It has to go straight to, I always do that, don't I? It has to go straight to the front of the compound. So I put the 3 there. Now, what you might realize, guys, as we've been doing some of these examples, is whenever we put a big number or coefficient right at the front of a compound, it not only affects the element that we want. For example, in this case, we'll have 3 sulfur now. That's all good. It also affects other elements that are in that compound or other atoms that are in that compound. For example, now, this hydrogen will no longer be 2. In fact, the big 3 here will multiply with the small 2 subscript to actually give us 6. Okay, this will change into 6. And now the previously balanced hydrogen that was 2,2 has now become 6,2. So now that's a problem. We've got to deal with that on this side as well. Okay, now in the same way, oxygen, okay, oxygen will now, the big 3 here, the big 3 coefficient will multiply with the small 4 subscript. 3 times 4 will give us 12. Now that kind of solved an issue for us because now the oxygen is balanced, but we still got one more part of this equation to balance, and that's the hydrogen, okay? So as we can see here, guys, on this side, hydrogen has 2, on this side, it's got 6. So I need to balance it on this side. So my goal now is to achieve 6 hydrogen atoms on this side as well, on the right-hand side, same as the left-hand side. So what do I multiply with 2 to get 6? I have to multiply 3. Okay, or 6 divided by 2 gives us 3. So I look for hydrogen, searching for my hydrogen atom. Here it is. It's all by itself. I just put that number 3 right in front of the thing. And what effect that has is that big 3 will multiply with the small 3, with the small 2 subscript of hydrogen on this side of the equation to give us 6. So no longer is it 2, it's now 6. And as a result of it being 6, that is balanced and everything is balanced. Okay. It's not that hard, guys. It's just a matter of knowing when to count the extra atoms, for example, when there's a subscript outside the bracket, and just knowing what to multiply with in order for the atoms to be balanced there. Okay, so that is that example there. So I'm just going to clear all drawings. Okay, we'll try one more example before we go. Okay, and I think that will basically finish us off for today. So I'm just going to, I'll pause the recording here and give you guys like about 4 minutes to complete this one, and then we'll finish up for today. So give this one a go. I'll pause the recording here. When we put the 2 there in front of the nitrogen and the hydrogen, that actually multiplies with the hydrogen as well to give us 2 times 3 is 6 in total. Okay, so that's going to be 6 now. Now, what the issue with that is that when we make that 6, now this side becomes imbalanced. Now we have to think about what do we multiply with this to make 6? Okay, and the answer will be 3. And now we look for the hydrogen atom on this side, looking, it's here. Put the 3 on in the front of that. Okay, now that also affects oxygen. So now oxygen is actually going to have 3 on this side. And so now we have to balance oxygen on this side as well. And how we do that is we put a 3 because oxygen is here. So 3 times 1 oxygen gives us 3. But now that also affects our copper. So now we have 3 copper on this side. Very simple to make 3 copper on the other side, on the right-hand side. We just multiply the Cu, which is all by itself, with 3, and that gives us 3. Okay, so I know that was a bit of a quick explanation because we are running a little bit on time here, over time. But yeah, that's how we would balance the equation there. Okay, let me know if any of that doesn't make any sense, and then I'm happy to help you out there. All right, so I'm just going to stop the recording here.